Hi there. This video explores how to work with equations that have algebraic fractions in them. Whole bunch of examples here. Let's buckle up and see where we get to. We'll be looking to multiply every term by the lowest common multiple of the bottom of the fractions and solve the equations from there. Let's have a look. Okay, in this first example, well, you can see that you have a fraction over 3 and another one over 2. The lowest common multiple there is 6. That's the lowest number that 3 and 2 goes into. So we'll multiply every term by that, not only the fraction terms, but the other term there, the 10 as well. And then we'll see where we are then. If we multiply that first term by 6, and the second term by 6, and the third term by 6. We chose 6 because it's the lowest common multiple of 3 and 2. It's the smallest number that 3 and 2 goes into. Now we'll do a bit of cancelling. The bottom 3 in the first fraction goes into the 6 twice. The bottom 2 of the second fraction goes into the 6 3 times. And then what happens is the 2 multiplies by the a to make 2a. So up here, the 2 that is resulting from our cancelling multiplies by the a. And then the 3 multiplies by the top there as well. So whatever's left after the cancelling multiplies with the top of the fraction, and 6 times 10 usually is 60. Then we'll just solve whatever the resulting equation is. 2a plus 3a is 5a, and that equals 60. We'll divide both sides by 5 to solve this equation. A will equal 12. And of course we can check by substituting in the 12 wherever there's an a into our original equation, and we should have the left hand side equaling the right hand side. That's a good double check there. So what did we do? We multiplied through every term by the lowest common multiple of the denominators. And then we did a bit of cancelling and then solved the resulting equation. Second example, the lowest common multiple of 3 and 4 is 12, so we're going to multiply every term by 12. Even that one on the right there. Then we'll do some cancelling. 3 goes into itself once and into 12 4 times. 4 goes into itself once and into 12 3 times. And then that 4 will multiply by the x, and that 3 will multiply by the x, and we'll get an equation out of that. A simplified equation. 4x minus 3x equals 60. 12 5s are 60. 4x minus 3x is just 1x, and that equals 60, so that was a pretty simple equation from there on. But once again, we multiplied every term by the lowest common multiple of the bottom of the fractions, the lowest common multiple of the denominators. We did a bit of cancelling, and then we solved the resulting equation. Here, the lowest common multiple of 3 and 2 once again is 6, and we'll see how that works here. Multiply the first term by 6, the whole lot of it. Multiply the second fraction by 6 and the third number by 6 there. 3 goes into itself once and into 6 twice. Now here we have to be a little careful. That 2 is supposed to be multiplying by the whole top. So we'll have to multiply the 2 by the m and the 2 by the 4. Be careful there. Treat it like an expansion of a bracket then, because it's effectively the same thing there. 2 goes into itself once and into the 6 3 times. And 6 lots of 1 will be 6. Now 2 times m is 2m. 2 times the 4 that we have to not forget about is 8. And then we have 3 lots of the m on the top of the second fraction, and that equals 3m. That equals 6. Now on this left hand side, don't think that you have to do the opposites of these things to move them. They're just collecting like terms here. So this is just a normal 2m plus a 3m. We don't have to do any opposites of that. So we get 5m plus 8 equals 6. Now that's just a two-step equation. We move the plus 8 first by doing the opposite to both sides, so we'll minus 8 both sides. Cancels out here, the plus 8 and the minus 8, leaving us with 5m. And 6 minus 8, you're taking away more than you've got there, you get minus 2 for that right-hand side. Then 5 is multiplying invisibly by the m, so to move him, to get the letter on its own, we'll divide both sides by 5. And there, so that'll cancel out on the left hand side. A multiplying of 5 and a dividing of 5 will cancel each other out, leaving us with m on its own, and that's what solving an equation really effectively is. We get minus 2 over 5. Now we can just write that as a fraction, minus 2/5, because the bottom of any fraction divides into the top anyway. Okay, so we multiplied through. We just had to be a little bit more careful at the top here to make sure whatever we our final bit from our cancelling, make sure that was multiplied through both terms at the top of that fraction there. So careful with those ones. Next example, we have 6 again for a lowest common multiple. It's a popular lowest common multiple here. We have 2 lots of a double barrel top here, so we'll just be careful with that. 3 goes into itself once and into the 6 twice. 2 goes into itself once and into the 6 3 times, and 6 times 15 is 90, I think. Anyway, really careful with the tops here. The 2 multiplies by both terms on the top. 2 times x is 2x, 2 times the 1 is 2, 3 times the x is 3x, and 3 times the minus 4 is minus 12. Make sure those top numbers go all the way through those tops of those fractions. That equals 90. Once again, we just have to join common terms here. We get a 5x there, a bit like we did in the previous example. And the 2 minus the 12 can be just done straight. You don't have to do the opposite of minus 12 or anything, because they're both on the one side of the equation there. You end up with 5x minus 10 equals 90. We'll solve that two-step equation in the normal way. We'll move a minus 10 by plussing 10 both sides, leaving us with 5x on the left-hand side and 100 on the right-hand side. We'll divide by 5 again. We've done that a couple of times already in this video. And x will equal 20 there. So we're just extra careful on the top here. When we've finished cancelling from the bottom, we'll make sure that we expand properly in the top sections of these fractions. Let's have a look at another one. Okay, now the lowest common multiple of 9 and 5. 9 5s are 45, and I can't think of any lower numbers than that 9 and 5 can both go into. So let's multiply every term by 45. The 9 goes into itself once and into the 45 5 times. The 5 goes into itself once and into 45 9 times. And we'll be careful once again with our expansions. Really careful with the second expansion this time, because we actually have a minus 9 in front of a bracket effectively on that second fraction. 5 lots of y makes 5y. 5 lots of 5 gives you 25. Now here's where we'll slow ourselves down. We have a minus 9 multiplying by a y. Now here's where a lot of students will go wrong. Suddenly we forget sometimes that there's a minus here. We actually have a minus 9 multiplied by a plus 2. Minus times a plus makes a minus answer. You can double check on that calculator if you like, but you get minus 18 for that last bit. A lot of students will get it wrong at that stage. That equals 45. Once again, these terms are on the left-hand side here, all of them really. And so when we're joining these, we don't have to do the opposites. We just have 5y minus 9y will give us minus 4y. We're taking away more than what we've got there. That's a number line sort of situation. 25 minus 18 gives us 7. That equals 45. We'll carefully finish off this two-step equation. We'll move a plus 7 by minusing 7 both sides, leaving us with 4y equaling 38. And then we'll divide both sides by a minus 4. There's a minus 4 that is invisibly multiplying by the 9. The opposite of that is to divide by minus 4. And we get 38 over, well, minus 4 or minus 38 over 4. As long as we've only got one minus there, that's fine. We can simplify that just a little bit further into minus 19 over 2. Alright, so being really careful with your expansions. We saw an example of that last example, but here we've got to be extra careful. We have a minus number multiplying through by both sections of the top of that second fraction. Easy to go wrong there if you rush it. Here we have an interesting situation when you've got an equation with a fraction on the left-hand side and a fraction on the right-hand side, and that's all you've got. There's a special opportunity of a bit of a shortcut here. We could do it a long way around, but let's see a bit of a shortcut. In these ones, the 5 from the bottom of one fraction can go up the top and multiply. The opposite of dividing by 5 is multiplying by 5 both sides. On the left-hand side, if we multiplied by 5, it would just cancel out the 5. So effectively, the 5 can move up to the top of the other side and multiply through carefully. And the bottom of the left-hand fraction can come up and multiply by the top of the bottom of the right-hand fraction can turn up to the top there. You saw it with the arrow. Just don't listen to me there. Getting muddled. Okay, be careful with it. It's expanding through a bracket, really. It's got to multiply by both terms on the top. 3 times 2x is 6x. 3 times minus 3 is minus 9. 5 lots of x equals 5x, and don't forget to do the last bit. 5 times 4 is 20. We're left now with an equation with letters on both sides. I encourage you to move the smaller letter term first. That's the recommended step for solving these ones. We'll minus 5x both sides, leaving us with x minus 9 equals 20, and we'll plus 9 both sides, leaving us with x equals 29. So fancy shortcut there. Only do this if you've got a whole fraction on one side and a whole fraction on the other side as well, and nothing else happening. We can't do this method if we've got anything else added to it over here or anywhere else. So it's a good one to use when you've only got a fraction on either side. Here we can't use it. We've got some weird things here. We've got the pronumerals, or the letters, on the bottom here. Let's be careful. Now, what do you think the smallest common factor is? No, the smallest common multiple of 2n and 10n is here. Now, 2n can go into 10n. So the smallest thing that they can both go into is actually the 10n. So I'm going to propose to multiply every term here by the lowest common multiple of the denominators, and that's 10n. If we multiply that second one by 10n, it actually just cancels out, but anyway. Now we can do some dividing first. 2n goes into 10n 5 times. 10n goes into itself once and into the top one once as well, and we get 10n times 6 there. But anyway, just like in the previous examples, we have the top cancelling result multiplying by the top of the fraction there. 5/8 are 40, and we get minus 1 lot of 4 on the second fraction there. It actually works out to be simpler than we think, and that'll equal 60n. We'll just simplify this left-hand side to make it 36 equals 60n. We'll divide by 60 both sides, and we get 36 over 60 equaling n. It's kind of on the wrong side, but we can just swap that. And we could simplify 36 and 60 because 6 goes into each of them. Matter of fact, 12 goes into each of them. So we'll just type that into our calculator and maybe get a simpler answer of 3 over 5. And then we'll just swap it at the end. So n equals 3/5. So that's a bit weird. We had pronumerals on the bottom here, but we still followed the same process. We multiplied through by the lowest common multiple of the bottoms, and then we did some cancelling, and we processed it from there. So even though they look trickier, you can still do the same process with the harder ones. Try and stick to the same rules and methods that you used with the easier ones. That's the best defense we've got against tricky questions. Alright, here's another one of those with fractions on both sides. This time the letters on the bottom here. So what we can do is we can take the bottom of 1 and multiply it across the opposite side up the top. So we can take x plus 5 and multiply it up the top with the 5, and we can take the x plus 4 and multiply it on the opposite side with the 4. Quite a fancy little trick here, and it gets our simplifying done nice and quickly here. So we can only do this, remember, when there's a fraction on each side and nothing else happening. So we've got 5 lots of the x plus 5 when that came up from the bottom of the right hand side, and that'll equal 4 lots of x plus 4 when that came up from the bottom of the left hand side. So we'll expand those carefully. Get 5x plus 25 on the left. If we expand the right hand bracket, we get 4x plus 16. And we'll solve that in the normal way. We'll move the smaller letter term first. Minus 4x both sides leaves us with x. Plus 25 equals 16 because these will cancel out here. A plus 4x and a minus 4x will cancel. And then we'll just minus 25 both sides. And we'll get x equaling minus 9 when the plus 25 and the minus 25 cancelled out there. Okay, so I like that shortcut. It can only work once again with the fractions on both sides there with nothing else happening. Don't try that if there's other things happening, like an extra thing added on the right hand side here or anything. But it's good to remember that little shortcut trick for those last couple. Alrighty, we've been through lots of examples there. In the end though, whether they were the simpler ones or the harder ones, we tried to multiply every term by the lowest common multiple of the bottoms of the fractions. We then solved the equation once we did a bit of cancelling, and we solved our equations with the normal solving of equation methods. Even though we started off with fractions, we can boil it down to normal everyday equations. And there we have it. I hope that helps. We've been through heaps of examples there and worked pretty hard, but you can always look at the video again and slow it down if you need to. But I hope that helps your solving of equations with algebraic fractions. Thanks for listening, and we'll catch you next time. PeterBlakeMaths.com. All the best with your studies.